Hi everybody, today we're talking about the math of all possibilities, which means we'll be talking about understanding power sets. We'll start by exploring a few small examples, then we'll build toward a general counting rule that we can use in real-world situations. The first thing we should say is, what is a power set? And a power set is simply a set of all possible subsets of a given set. Our notation is P of S. Sometimes it's a fancy P, sometimes it's a regular script P, but I just want you to think P for power. Our first example is a set A has two elements X and Y. Let's find all possible subsets of A. We'll start with the empty set because the empty set is a subset of every set. Then we could have just X, just Y, or both X and Y. I want you to notice that we had two elements in our set and we have four elements in our power set. So let's make that just a little bit bigger. This time our set B has three elements A, B, and C. Because listing is possible but a little bit inefficient, we need to have a strategy of how we're going to write down our subsets. I'm going to group by size, meaning I'm going to look at how many sets have no elements, one element, two elements, or all three elements. No elements is easy. That's the empty set. There's only one subset with no elements. If I look at how many subsets have one element, well, that would be just A, just B, or just C, so that's a total of 3. If I look at two elements, remember, order doesn't matter when we look at sets. So when I say AB, I don't also say BA. So I just have AB, AC, and BC, which is a total of 3 subsets. Then lastly, when I look at all three elements, there's only one way to write that, A, B, C, which is one more subset. So with 3 elements in my set B, I have a total of 8 subsets in my power set. Let's see how combinations are related to power sets. When we were looking at our set B with 3 items, we looked at how many ways could we choose 0 items, 1 item, 2 items, or all 3 items. And we found that the combination of 3 choose 0 was 1, the combination of 3 choose 1 was 3, the combination of 3 choose 2 was 3, and then the combination of 3 choose 3 was 1. When we added those together, we got 8. But let's write 8 as 2 cubed. This shows us the connection between combinations and looking at a power of the number 2. Let's expand that by looking at the key idea between why this is a power set. I want you to think about each element in our original set. When we form a subset, each element is either in or out, so every element has 2 choices. Because each element has the 2 choices, with n elements in a set, there are 2 to the n possible subsets. This is why we call it a power set. The size grows by a power of 2 every time we add another element. Let's try a quick application. Let's say we are buying a computer and at the store we have to select from a bunch of possible add-ons. And in this case we have 6. You can add on RAM, SSD, GPU, warranty, Wi-Fi, or a webcam. So when we look at all the options that are available, for each one we can either buy it or skip it. We have 2 choices. Every possible package then is a subset of the add-ons. Because we have 6 possible add-ons, that gives us a total of 2 to the power 6, which is 64 packages. Remember, this includes everything from selecting no items all the way up to getting all 6 items. And the advantage to having the shortcut of using 2 to the n is that we don't have a need to list out every package, we just compute the total.